A discovery announced as evidence from the first moments of the universe later became explainable by dust drifting through our own galaxy. That sounds like the kind of reversal that should only happen if the data were flawed, or the scientists careless. Yet the official joint analysis by the BICEP2 Keck array and Planck collaborations reached a far stranger conclusion. The signal was real. The discovery was not. At the center of the story is an image. A map filled with faint swirling patterns known as B modes. For years, cosmologists had searched for those swirls because they were supposed to be the fingerprint everyone wanted. If they came from the early universe, they could provide the first direct evidence that cosmic inflation had happened, a violent expansion thought to have occurred in the first fraction of a second after the Big Bang. Then, at the South Pole, a telescope called BICEP2 appeared to find them. The observatory sat in one of the coldest and driest places on Earth, staring into a carefully selected patch of sky. Between 2010 and 2012, it collected polarization data from the cosmic microwave background, the ancient light left over from the early universe. When researchers processed the measurements, something extraordinary appeared. The swirl map looked almost exactly like what success was supposed to look like. The signal was strong. The pattern matched expectations. The reported detection significance exceeded 5 sigma. In March of 2014, the collaboration announced its result publicly. The discovery was presented as the first direct evidence of inflation and primordial gravitational waves. The image spread everywhere. Conference stages, news headlines, scientific discussions. The swirl map became more than data. It became a picture of the beginning of time. And at that moment, the story already contained the detail that would eventually dismantle it. Buried beneath the confidence was a condition. The measurement alone was not enough. The interpretation depended on something else being true. The signal had to come from the early universe rather than from material much closer to home. Inside the scientific paper, there was a caveat. Dust had not been fully excluded. That warning did not erase the excitement. The signal still looked convincing. The pattern still matched the prediction, but the discovery rested on a fragile dependency. Another source could potentially create the same swirls. The B-mode image had become evidence. But it was evidence that still required validation. The problem was that the sky is not empty. Between Earth and the edge of the observable universe sits the Milky Way, filled with microscopic dust grains threaded through magnetic fields. Those dust particles emit polarized light. And under the right conditions, they can create B-mode patterns too. The swirl map itself could not reveal which source had produced it. The image remained the same. Only its possible meanings multiplied. For a while, that uncertainty remained manageable. The observed field appeared relatively clean. The contamination seemed likely to be small. Then another dataset arrived. Planck. Unlike BICEP2, which focused intensely on a specific region of sky, the European Space Agency's Planck mission surveyed the entire sky across multiple frequencies. Its foreground measurements provided something BICEP2 lacked: a broader view of the dust. When researchers examined Planck's maps, a troubling reality emerged. Dust was not confined to obviously bright regions. It appeared even in places that looked unusually clean. The BICEP2 field was among the quietest parts of the sky. Yet Planck showed that quiet did not mean dust-free. The image that changed everything was not another B-mode map. It was a dust map. Across the sky, faint structures emerged, where many researchers had hoped they would be almost nothing at all. an important option disappeared. The assumption that location alone could protect an observation from dust contamination began to collapse. The audience's trust shifts here. Not away from science, away from the announcement. Because independent evidence was now challenging the interpretation that had made the discovery revolutionary. The swirl map returned. It looked exactly as it had before, but now it carried a second explanation. And that explanation refused to go away. There was only one path left. The datasets had to confront each other directly. Not in headlines. Not in speculation. Inside a joint analysis, researchers combined information from BICEP2, the Keck array, and Planck. The question was no longer whether the signal existed. Everyone agreed that it did. The question was whether any part of that signal remained uniquely attributable to primordial gravitational waves. This was the audit. The stage where every surviving assumption would be tested against independent evidence. Graphs replaced celebrations. Likelihood curves replaced announcement podiums. Competing explanations were forced into the same statistical framework. And as the data sets merged, interpretive freedom began to shrink. Dust explained more. The primordial contribution explained less. The pressure in the story comes from something unusual. New information is normally expected to strengthen confidence. Here, every new layer of information reduced it. The measurement survived each round of scrutiny. The meaning did not. Eventually, the joint analysis reached its conclusion. There was strong evidence for dust. There was no statistically significant evidence for tensor modes, the signature expected from primordial gravitational waves. The discovery claim that had electrified cosmology no longer survived the combined evidence. The swirl map remained. The announcement did not. What failed was not the telescope, not the data, not the observation. BICEP2 had measured something real. The mistake was believing that measuring the pattern automatically revealed its origin. The same image that once seemed to carry a message from the first moments of the universe could also be produced by dust inside the Milky Way. The signal never disappeared. Only certainty about the signal's source disappeared. And that distinction changed everything. By the end of the story, the opening image means something entirely different. The B-mode map first appeared as a cosmic fingerprint, a direct trace of inflation itself. It ends as a warning. A reminder that measurement and interpretation are not the same thing. The final joint analysis did not reveal a failure of science. It revealed science continuing after a victory had already been declared. The discovery vanished. The verification remained. And in the end, the most important result was not the signal that scientists found. It was the evidence that forced them to ask what that signal actually meant.